Hello all, hope you guys are doing well. This is our semester project for managing integrated project delivery. We have myself, Aaron, along with Adam, Taylor, and Ameet. So I'll give a brief introduction of the project overview. It's the Engineering Interdisciplinary Complex at San Diego State University with Clarke Construction Group with proposed start date of November 5th. And then obviously the proposed finish date, August 1st, 2019, which we will see an in-depth schedule a little bit later. With that, I will go ahead and hop into the first issue that we addressed. In order to unite the team a little bit more, we created a team charter, and along that with a project mission statement. So I will go ahead and read out the project mission statement. To deliver a high-performing building where the world's best students are equipped to alter the future, our team will do this by working together to empower the front lines to innovate how we build this project. Our team will strive for quality with everything that we do. With that, I'll hand it off to Taylor. She's going to talk a little bit about colocation.
Thanks, Aaron. So going over colocation and enhancing team communication. Since our project is in schematic design and going into design deliverables, we propose hosting a co-location space in an existing building to reduce the space's construction time and use our limited budget wisely. We are kindly requesting San Diego State University to loan the integrated team 3 to 4 classrooms in an adjacent building on the site, such as the life science or physical science buildings, for the project's duration. Proximity to the site is critical for the success of the team communication. In the space, there will be an open room for shared offices, private offices for the owner, a small huddle space, the big room, and at least one small conference room. To increase the team's communication, the big room will need to include a wall space for the team to present and pin up important information such as the schedule and posted metrics. We recommend at least a daily safety briefing as well as weekly meetings with sub-leads to go over the schedule to ensure subs are ready to be on the job when their time comes. And this includes a 3-week look ahead.
And so our site utilization plan is here attached. As you see, the site, our team understands that the site is going to be super compact. We also understand we'll be operating in an active campus, and so student, faculty, and visitors are of the utmost importance. You can see here the pink location is where our team is proposing the parking. There is an adjacent parking lot. We do not believe there will be room on the site to host trade partners' cars. We do request a few spots close to that field office that Taylor referenced before. As you can see here, we've divided the site utilization plan up into 2 separate phases. The first phase being getting through site work and structures, and so this will be the logistics as we're actually building the buildings. You can see right down the middle of the north and south wing will be our crane path. We will have crawler cranes in here in order to erect the structure. On the north side of the site, which is our priority of the site, and we'll talk to that a little bit later in the schedule, we're utilizing the North Promenade as a delivery equipment and traffic flow. So we will have the North Promenade courtyard as this laydown for our north building. All the building materials will be laid down in the north courtyard. And then on the south courtyard, it's the same exact flow, just mirror image down. We do have a specific spot for our trade workers in order to have a nice lunch and break area. We do plan on investing in actual trailer restrooms, so you won't have your typical porta-john restrooms here. We understand that when the trade partners know that we care about them, they perform at a higher level with more quality, and we end up with a safer product. When we move into phase 2, we'll have the structure completely built, and now we'll start building the envelope, and we'll start doing the rough end phases as well as the finish phase. And that will take the laydown areas and we'll put it in between the 2 buildings. That'll free up space to allow our north and south promenade courtyards to be worked on. There is a ton of hardscape on this project, and so we really need to get started on that as soon as possible, which will happen the second the structure is done. You can see also in the second phase, we have added a gate 3 And that is now where our traffic flow will be. All equipment, deliveries, manpower, everything will be coming through the gate titled number 3. We've also taken special care, you can see with the black arrows, to make sure that students have pathways all around our site so they can get around safe without having any construction exposure. The red also symbolizes an entire fence around the perimeter of our project site leading up to the existing buildings.
Our team has decided to move with the structural steel system for two main reasons. First, we found several case studies and technical researches that have proven steel as cost efficient, readily available, and a recyclable resource. Secondly, our project is situated in a seismically active zone 4 category, and that steel is the material of choice in such regions to provide earthquake resisting systems. Further, after careful considerations of different types of steel structures as given in the table, we selected moment resisting frames that offer high architectural and program flexibility at economical cost while absorbing substantial inelastic energy dissipations during earthquake. Apart from those, the other reasons for going with steel structure included that the weight of the system reduces considerably, decreasing the foundation cost. Due to lesser maintenance on steel, it becomes economical in the long run as well. They can match the design requirements of the existing architectural concepts at San Diego State University. The building components are typical and repetitive, due to which the speed of construction will be higher. The components are effectively transportable. Steel allows for longer column to column spans than RCC, which offers more freedom in multipurpose designing at a later stage of the project.
So, as Ameet already mentioned, this decision to move into steel structure allows us to go with longer spans. And while we were reviewing the project narrative, we noticed that the structure grid was typically to be 31 feet and 6 inches, but then in the architectural drawings, it was actually at 21 and 6 inches. So the left drawing is showing the updated grid on the south building. And after discussion with the integrated team, we decided that we should revise the plans for both buildings to the standard 31 feet and 6 inches grid, which is going to cut down on material costs, is a more reasonable span, and aligns more with the owner's wish for flexible floor plans. Our next steps will be involving a cross-disciplinary team analysis through updating the BIM model and then meeting in our colocation big room. The drawing on the right is also the south building, but of the third floor plan. And the proposal here is to remove stair 5 and rework the bathrooms to align with the lower floors, which is going to create plumbing and constructability efficiency by having all the stacked bathrooms the same. Stair 5 is going to be replaced with a ceiling hatch, provide a secondary access to the mechanical space in the attic, which will be cheaper and faster install while still meeting the building code requirements.
So coming to some of the changes that we have decided to reduce our costs. So first is the drywall. Drywall helps construct non-load bearing structures and also coverings and ceilings. The sheet will be used diversely depending on different properties they possess, such as fire resistance, fireproofing, and soundproofing. The prices start from $10 per sheet of size 4 by 8 feet and half-inch thickness. Throughout, we have replaced the masonry partitions with these drywalls, and the columns will also be cladded with these panels and painted accordingly. The sheets are cost-effective, readily available in the various sizes, easy to cut, and allow quick installations. Upon calculation, they found approximately 18 to 20% of the spaces are office or conference rooms. Therefore, we will be using nylon carpets in these areas. Nylon carpets cost around 3.5 per square foot and offer one of the highest return on investment compared to other types of carpet flow options. It's perhaps the most durable carpeting material and suitable for high traffic areas. The remaining 80% of the areas consists of labs, study desks, and supporting areas. So we will be using stained concrete in these areas, which is available at 1.5 to $2 per square feet, thus saving the estimate overall in the finishes by 15%. Next, we plan to replace copper feeders with aluminum ones. If we check the data since 2014, aluminium's market prices are far more stable than copper's. All aluminum conductors have the inherent quality of weighing roughly 50% less than copper. If it helps make construction installation techniques more accessible, such as bending, pulling wires, training cables in confined spaces, etc. It is also significantly less expensive as feeders made of aluminium are typically 15 to 20% less expensive. Employing aluminium has predicted to save 5% of the target amount, about $324,216 in our project. So this is our final revised estimate sheet. As discussed in previous slides, the changes are incorporated here. We have highlighted in yellow the work descriptions that have severe implications on the overall cost. Hence, we started with value engineering with the top most expensive work packages. Since we decided to construct with steel, we anticipated some additional costs such as priming the steel and fireproofing it with vermiculite concrete. Yet after full consideration of the system, we are saving 30% on the framing overall. Again, the replacements with drywall and flooring considerations of carpet and polished concrete contributed to 20% more savings. Finally, adding the aluminium electrical cables reduced the cost by more 5%. Total in our cost estimate decreased to 62.3 millions from 66 millions, which was the initial target estimate. So here is the location that we have decided to put the glass box entrance and the required calculation for that. In this, we have considered structural supports which will be easily attached to the building, and we need not redesign something especially for this part because our structure is already a steel structure, so it is easy to connect with them. And we can also with just a little bit of more investment, we can have a spider glazing system as well in this location.
So, as Ameet said, not only are we getting cost savings, but we're also getting some schedule savings with the switch over to steel. And our team has put together, at the request of the owner, this a tact plan. This tact plan shows both the overall schedule on the job, which you see on the top here, but we're also able to expand this into a daily schedule. And so you can see our plan start, and our plan finish dates along the left. You can see how we've color coded them out so that you understand flow. We've also taken the liberties to break down the design package so that we're not waiting on the entire design development or the construction documents. We're going to go ahead and release these in pieces based on feeding construction and keeping construction active. This will also help with the fire marshal review, as Aaron will mention here in a minute. You can see it, as we mentioned with the site logistics plan, we're starting with the north building, then we're transitioning into the south building, followed up by the center courtyard areas. Again, we believe that this schedule gives us plenty of detail and helps to provide a reliable flow of work in order to communicate that with all trade partners and really all stakeholders involved.
Thank you, Adam. So for this issue is questioned whether the chilled water for the new buildings would come from that central plant. So to solve this and look into it, our team did an in-depth study of the design civil drawings. We see here C201. The drawings do not show the line entirely to the central plant, but we can see them leaving the new building structure. We also see that the design narrative you see in the top right clearly states that the chilled water will come from the central plant. Therefore, our recommendation is that the design team finish out those chilled water connections just to provide clarity with all parties involved. In regard to the owner furnishing owner installed equipment, we have a few action items and recommendations. However, I wanted to clarify the differentiation here with OFOI and OFCI, so that owner furnished contractor installed items, and we see that in spec section 01640 on the right here, and you can see the requirements and recommendations there. However, with the owner furnished owner installed equipment, we recommend that there are early deadlines set and that the owner sends those schedules ahead of time. And additionally, we request for early submission when possible. And then finally, we believe with this IPD and co-location space that we hope to implement, when this equipment is incorporated into the entire design, it will be easier to install it into the existing utility system with minimal disruption to budget and schedule due to the IPD and colocation space that is available. In regards to the fire marshal review issue that Adam kind of touched on earlier, just the backlog possibly inhibiting project schedule, we have made some recommendations moving forward. We believe that these can bring swift resolution to the issue and ensure that the project remains in budget and on time. So they're as follows. First, just sending in submittals for review as soon as they are received, and that will be on the GC. Secondly, fire marshal reviewing the north and south buildings separately. Thirdly, using the code location space to review codes prior to the fire marshal walkthrough, and that'll be a team effort with the GC, with the owner, architect, and subcontractors. It's imperative if we want to remain on schedule that this inspection for both the north and the south is passed on the first time, and so we want to utilize the co-location space to go ahead and do that walkthrough, primarily looking at IFC and NFPA codes. Could be possibly something that's added to the punch list, but if the inspection is not fully passed on the first time, it could delay the entire project schedule. And so for this onboarding presentation, we just wanted to make a super quick 5-minute presentation to give to any new team members, just to ensure that we were all on the same page regarding vision, values, that kind of thing for the project. And so it's super basic. I'll run through it really quickly, not the full thing, but just give you a brief overview so you can kind of see what we'd be giving to new team members when they're onboarding. So firstly, obviously the title slide. The brief project overview, giving them a picture of the site, will outline where the parking will be, those kind of logistics. And then I think it's important that they know the cost and the proposed start and the proposed finish. Then we would do the mission statement, and I won't read it again, but there it is. And then we'll briefly define IPD and lean for them, just emphasizing the aspects of it that we want to especially keep in mind on this project. And obviously we're going to touch on safety. It's an integral part. We'll have daily safety briefings. Safety is it's an important thing. We hear it all the time, but we just want to really emphasize that. And then the 3 C's of this project, one being care about fellow workers, have the courage to speak up, and then the courtesy to thank people who speak up to you. And then finally, just some other important notes about the site. So with that being said, thank you all so much for your time. And we look forward to hearing feedback on the presentation soon.